Right. Now, kids, in this question, they're asking us to find a potential difference. So let's read the question first. When the potential difference across AC becomes 21, find the potential difference across BC here. So they're asking us to find the potential difference across this 30 microfarad capacitor. Right. To find this capacitor, we need to arrange the circuit in a different way. So we have to simplify this circuit into something like this. So BC, this is the 30 microfarad capacitor, and these are rest of the capacitors. I circled that. This is the rest of the capacitors. We need to simplify into something like this. Right. Let's work on it. Here, so you have to identify what are the capacitors that are series, that are parallel. So let's start with parallel resistors because it's easy to add parallel resistors. You know these two resistors are parallel. So parallel resistors can be added like this, C1 plus C2. So the equivalent of these two has to be 10 microfarad. You should know that. Right. And these two will be 40 microfarad. Right. Let's keep adding them. And now this 40 microfarad and this 10 microfarad are in series. You know how to add them. 1 over C equals 1 over C1 plus 1 over C2. So when I add these two, in that method, I get 1 over 10 plus 1 over 10 equals 1 over C, 10 over 2, 1 over C. C becomes, let's take a reciprocal, it's 5 microfarad. Here the same scenario, 1 over 40 plus, again you know it, 1 over 40. So 2 over 40, that's equals 1 over C. When taking the reciprocal value, 40 over 2, that becomes 20 microfarad. So let's simplify the diagram a bit more now, right, into something like this. So we have 5 microfarad, and then we have 20 microfarad, and last we have 5 microfarad. Let's look at the diagram. Yes, 10 10, yeah, 5, 40 40, that's 20, and 15. I've add 15 right here, it's 15, and we have BC 30 microfarad, and it is in series with this circuit. Right. So let's draw it. BC 30 microfarad. So this is C, this is B. I can add these three now because these three are, you can see it, parallel. So 5 plus 20 and 15. Yes, you can add it. 25 plus 15. Yes, 40. Right, 40 microfarad. Right. So we can simplify it furthermore into two circuits right here. Now this we have found it as 40 microfarad, exactly 25 plus 15, 40, correct. So we have 40 microfarad and 30 microfarad that are parallel. Right. Now again you should know this theory, Q equals CV. So we know yes, V equals Q over C. So V proportional to 1 over C. So let's take this ratio. 1 over 40 is to 1 over 30 ratio. That must be equal to potential ratio across AB and BC. Right. V1 is to V2 equals, right. So I have to multiply this by a, yes, common denominator value. Let's take 120. So 120 into 40. Yes, go ahead. That's 30 and 40. Yes, 3 is to 4. Right. So then we can simplify 3 is to 4 ratio. Yes, 21 volt, right? The fraction will be 3 over 4 and 4 over 3 over 7, 4 over 7, right? Last simplification. So I get for 3 over 7 for this 30 microfarad, right? So that into, yes, 21, I get 9 volt. So across BC, potential difference, now we know it's 9 volt. And across this one, it has to be 12 volt for it to be correct. Total potential will be 21 then. So let's see the fractional value here. We got 4 over 7, that multiplied by 21, cancel off 3 and 4, 12 volt. That's correct. So the potential difference across BZ, now we know it's 9 volt. Here we have used potential potential divider method.